Hello and welcome to the TRS Technical Process Tour. I am David Fleming, Vice President of Sales and Marketing, and a founder, managing partner, and secretary of the Board of Directors of TRS Group. In this tour, you will see how our unique and highly effective method of electrical resistance heating, or ERH, technology is deployed for the safe, fast, and certain remediation of contaminated sites. ERH is an in-situ thermal remediation technology that uses standard line frequency electricity to change a liquid to vapor. ERH also uses vapor recovery or multi-phase extraction for rapid in-situ remediation of soil and groundwater impacted by chlorinated and non-chlorinated volatile organic compounds, or VOCs, at dense non-aqueous phase liquid concentrations, or NAPLs, and fuel hydrocarbons including non-aqueous phase liquids, or NAPLs. TRS ERH technology uniformly heats the target area to steam temperatures as high as 100 degrees Celsius, converting the subsurface moisture and contaminant to steam and vapor. Thousands of pore volumes of steam are passed through the target treatment volume. Steam acts as a carrier gas, stripping the VOCs to the vadosome where they are captured in the vapor steam recovery system. The steam and vapors are extracted to the surface where the vapors are treated prior to release to the air. TRS ERH uses common three-phase electricity from a municipal power line. Three-phase electricity at either high or low voltage is connected directly to our ERH specialty equipment for remediation. Alternating current electricity is connected directly from the high voltage municipal line to our power control unit, or PCU. TRS owns the largest and most diverse ERH specialty equipment fleet in the world, including a wide variety of PCU options, giving us the capacity to operate up to 16 remediation projects at once. The diversity of our fleet, including the largest PCUs in the world, gives us the capability of applying ERH on large and small sites. Our PCUs are specifically designed to accommodate the full range of soil conductivities that can be encountered at a given site and to easily manage the changes in soil conductivity that occur as a site is heated. The larger PCUs use high voltage electricity, 12.4 or 13.8 kilovolts, directly from the municipal power line. The smaller PCUs use lower voltage electricity, 480 volts, that is stepped down from the high voltage line using a utility transformer. Safety is first at all of our project sites. TRS has an impeccable safety record with over 1 million hours worked. Our EMR rating is less than 1. All of our ERH specialty equipment is interlocked for safety. The equipment compound and remediation area is surrounded by security fencing, including a lock gate and perimeter motion detectors with real-time video surveillance. If unauthorized personnel breach the security perimeter during operations, the ERH system shuts down automatically and the local police are notified. If a piece of equipment shuts down for any reason, the ERH system ceases to operate. Our PCUs also include an emergency shutoff switch. Following our extensive startup routine, our ERH systems are remotely monitored and operated. A standard phone line, high-speed modem, computer or smartphone, and accompanying software is required to conduct remote operations and monitoring. System control and data acquisition are performed on dedicated onboard computers or smartphones. Windows-based data acquisition software provides for the collection and storage of subsurface temperature, power, voltage, current, and operational status information from all system components. Operations personnel can monitor and control the heating process and download data remotely. This allows our project managers to access and display real-time system operations information from the subsurface, the electrodes, the PCUs, the ERH condensers, and the water and vapor treatment systems. Remote monitoring and operations of our ERH systems saves time and money. This is an example of the main operations screen. The screen displays the electrical power being applied to the remediation area in volts, amps, and kilowatts. The ERH system can be turned on and off at the main operations screen. We can also access other operational and monitoring screens shown in the blue boxes at the bottom. The ERH remediation system is designed to remediate the subsurface treatment volume that is initially defined by the property owner or their representative. TRS works closely with the owner or their representative to develop the specific ERH remediation parameters, including recommendations for the size of the treatment area in square feet, the depth interval requiring remediation in feet below ground surface, the resulting treatment volume in cubic yards, the contaminant cleanup goals and numerical values or percent reduction, and contracting methods regarding performance guarantees or standard fixed price remediation contracting. Electricity is directed into the subsurface treatment area using heavy cables that are connected from the PCU to the electrodes. TRS designs its electrodes to deliver energy into discrete subsurface intervals that contain the contaminant mass, eliminating wasted energy during the remediation. Our patented multiple element electrode design also provides fine control of individual subsurface electrode intervals and the flexibility to turn areas off that clean up quicker, then redirecting energy into the areas that are slower to clean up. This saves time and money. Once all of the equipment is connected, TRS conducts a startup routine to ensure safe and proper operations. During the startup routine and full operations, TRS personnel conduct step and touch voltage surveys to ensure that the work area is safe. Electricity flows evenly between the electrodes. It is the water or moisture that conducts electricity and the soil's resistance to the flow of electricity that generates heat. The flow of electricity between the electrodes heats the subsurface to the design temperature or up to steaming temperatures. The type of contaminant and percent reduction or remedial goal desired are two of the primary metrics that determine the design temperature. Each electrode is co-located with the vapor and steam recovery well, providing complete and overlapping subsurface vacuum and full capture of vapors and steam. TRS establishes and maintains negative pressure vacuum during ERH operations to ensure complete capture of vapors and steam, including under operating facilities. This provides safe and certain elimination of vapor intrusion. TRS also uses multi-phase recovery systems for heat-enhanced free petroleum product recovery. A vacuum blower is used to provide continuous subsurface negative pressure vacuum. Vapor and steam conveyance piping is made of chlorinated polyvinyl chloride or CPVC plastic pipe that can withstand the design temperatures. Each of the recovery wells are connected to the conveyance pipe that routes the vapor and steam to the condenser. The water in the subsurface conducts electricity between the electrodes. Low permeability areas, higher in clay and silt, often contain the contaminant mass, and they are more conductive or low resistance pathways. These areas attract the electricity first and heat up slightly quicker than the surrounding formation. TRS ERH creates a phase change by boiling the VOC and water into vapors and steam. It is the physical action of boiling and steam stripping that liberates the contaminant from the low permeability lithology and surrounding formation. ERH combined with multi-phase extraction or MPE can also be used for remediation of long-chain petroleum hydrocarbons as NAPL or NAPL, including fuels, creosote, and heavy oil. The heat generated during ERH lowers the viscosity and specific gravity of the heavy hydrocarbon, making it possible to recover it to the surface using entrainment extraction. TRS ERH combined with multi-phase extraction is used to remediate soil and groundwater impacted with kerosene, diesel, jet fuel, creosote, and compounds as heavy as solid grease. Temperature monitoring points, or TMPs, are located between the electrodes. Each TMP contains strings of thermocouples or temperature sensors installed at every 5-foot subsurface interval. Subsurface temperature data is uploaded continuously to the on-site control computer and made available for remote monitoring. This provides a complete subsurface temperature profile throughout the ERH remediation. The steam condenser separates the contaminant vapors from the steam. It is a good example of Henry's Law. The majority of the contaminant mass, or greater than 99.9%, remains in the vapor state. The resulting condensate is circulated in the cooling tower. The cooled condensate is used as makeup water for the equipment and as drip water into the electrodes to maintain moisture at the soil electrode interface. The condensate is clean and can be directly discharged to the local sewer. However, TRS provides more certainty by treating the condensate with liquid, granular activated carbon prior to discharge. A small amount of water at the end of the ERH remediation may require disposal. The vapors are treated prior to discharge to the atmosphere. The most common vapor treatment method is granular activated carbon, or GAC. Thermal and catalytic oxidation are also used for sites containing greater contaminant masses and mixtures of contaminants. TRS also owns steam regenerated carbon systems that provide more certainty with the cost of vapor treatment. TRS is also in the process of acquiring refrigeration condensation vapor treatment systems. In all, the TRS-ERH process is rapid and cost-effective and provides a complete and certain solution to source area treatment. TRS-ERH solves the matrix diffusion problem. In addition, we can combine remedies for source, zone, and/or to incorporate area plume treatment. We are leading the industry with developing low-temperature ERH for heat-enhanced bioremediation that provides a more rapid solution for remediation of dissolved phase plumes. TRS-ERH can be applied underneath existing buildings and other permanent public structures. Average results rapidly within 3 to 6 months reduce contaminant levels by greater than 99% in soil and groundwater. TRS offers a below-grade option that is applied below the surface of the site and allows unrestricted access to the treatment area. Most importantly, TRS will guarantee ERH remediation.